Hi everyone, this is part two of the video where I'm showing you how to apply the t-test in R. And if you remember in part one, I showed you how to apply the t-test to one particular problem. We were trying to compare the hotel ratings given by domestic guests to the hotel ratings given by foreign guests, okay? And we were actually testing these two particular hypotheses, this HO versus this H1. And we actually, after we ran the test, we actually found evidence to support H1. So our conclusion was that on average, domestic guests gives higher rating than the average provided by foreign guests, okay? And we were able to conclude that because the p-value was less than alpha. So you can check out part one if you need a refresher. But yeah, so in part one, we were able to find statistical significance for the observed sample difference between domestic guests and foreign guests. Okay, and I wrote all the conclusions about statistical significance in these two paragraphs. So you can go ahead and pause the video and read this if you need a refresher of our previous conclusion, okay? We already discussed this in part one, but again, if you want a refresher, you can go ahead and read this again, okay? So that's great. So we found statistical significance, but as I said in this last paragraph, um, we know when we conclude that there is statistical significance, we can conclude that the difference between the sample means is real, okay? So the difference between the average score provided by domestic guests and the average score provided by foreign guests is real. Moreover, we can conclude that on average, domestic guests give us higher scores than foreign ones, okay? So that's perfect, but how important in practical terms is this real difference, okay? Um, Statistical significance only tell us that the difference is real. Again, that you can expect the difference that we are observing here in this sample to also hold at the population level. In other words, statistical significance tells you that the difference that you are seeing here is not a fluke. It's something that you expect to see in many other samples in the future. Okay, that's another way of thinking about this. But that's great. So we know that the difference is real, is expected to show up in future samples and also at the population level. But how impactful, meaningful that difference is in practical terms. In other words, if you look at the difference between the average scores, it's kind of like 1.5 units. So difference between this value and this value is around 1.5. Um, does that even matter? Does it matter that the average score provided by domestic guests is 1.5 higher than the average score provided by foreign guests? Does that matter? So, does the management of this hotel will do anything different, or or will they need to do anything different because of that? Okay. So, what are the implications of this in practical terms? That is the evaluation of practical significance, and that's what we're going to discuss now. Okay. Okay, guys, so to evaluate practical significance in a t-test, like when you do a t-test to evaluate practical significance, um, the best way we can use is to compute something called the effect size, okay? And we're going to discuss in this video what is the effect size and how to compute it. But before doing that, I want you to understand something. The effect size, unfortunately, it's only a proxy to evaluate practical significance. In other words, the effect size is not perfect. It's not a perfect metric of practical significance. It's only a proxy. It's only a first step to evaluate practical significance. At the end of the day, we need to combine the effect size with input from people with domain knowledge. Okay, so that's the idea that I want you to understand before we even discuss the effect size. The effect size is not perfect to evaluate practical significance. It gives us an idea of practical significance, but But we need, at the end of the day, um, people with domain knowledge to tell us how practically significant the difference is. All right. And the best we can say is something like this. So when the effect size is small, all right, then you'll be able to say stuff like, well, when the effect size is small, it's not very likely that people with domain knowledge will find this as practically significant. When the effect size is moderate or medium, you'll be able to say, well, there is some chance that people with domain knowledge will find this difference as practically significant. And when the effect size is large, then you will be able to say, it's very likely that people with domain knowledge will find this effect as practically significant. Now, in this specific example, who are the people with domain knowledge? Well, the managers of this hotel, people with expertise and experience in the hospitality industry. Okay, so we need the input from those people to come up with a final evaluation of practical significance. But definitely, um, the first step towards that could be the effect size. Okay, so first, let's define the effect size. The effect size is the degree to which HO is believed to be false. In other words, like how, like in terms of the truth, how far away is the truth from what HO states? Okay, so in this case, how wrong is this hypothesis? Okay, how wrong is that hypothesis? What is the magnitude to which HO is false? Okay, that is the effect size. But how to compute the effect size? So that's a definition, but how to compute the effect size? Well, to compute the effect size for a t-test, we are going to use Cohen's suggestion. Okay, so there is a very famous article written by Cohen, a power primer in 1992, and in that article, Cohen mentioned that to evaluate the effect size when you do a t-test using independent samples, which is our case, you can use that metric right here to compute the effect size. And that the metric is just the difference between the means of the two populations divided by the common standard deviation. So here we assume that both populations have the same standard deviation and that we can kind of estimate a common standard deviation. Okay. And then Cohen says that, if the effect size computed using this formula is around 0.2, it's a small effect size. If it is around 0.5, it's medium. If it is around 0.8, it's large. Okay. Now, how do we actually estimate this? Because these are population parameters, the population means and the population standard deviation. Well, we need to resort to the sample mean. So we need to compute the absolute difference. Actually, we need to compute the absolute difference, not the difference, but the absolute difference between the sample means x bar 1 minus x bar 2. And then we need to divide that absolute difference by SP. What is SP? It's the pooled standard deviation, and the pooled standard deviation is what allows us to estimate the common standard deviation. Okay. A reminder that the pool standard deviation SP is computed like this, and as you can see in the formula, the pool standard deviation kind of combines both standard deviations, the standard deviations from both samples. Okay, S1 squared, S2 squared. Okay, those are the sample variances, but at the end it combines the sample standard deviations from both samples. All right, knowing that, let me show you how to compute the effect size in R. Okay. And I'm going to start by computing the pooled standard deviation. So take a look at that formula, and I'm going to create an expression in R to compute that quantity. Okay. Here it is. So I just used the formula that I show you. I created an expression in R right here. Okay. I'm just in that expression, I'm just applying that specific formula. Okay. Remember that the sample sizes are 43 for both samples. So here, that's why we have 42. Okay. Because here we have N1 minus 1, N2 minus 1. So you can go ahead and, compare this formula to this expression, and you will see that it's just a faithful application of that formula. I stored the pool standard deviation in that variable, and sure enough, when you execute that code cell, you get that the pool standard deviation is 2.53. And well, after that, we apply this formula to get the effect size, the absolute value of the difference between the sample means divided by the pool standard deviation, right there. ABS, absolute value of the difference between the sample means, so the mean from domestic scores minus the mean from foreign scores, okay? And that absolute difference divided by the pool standard deviation that we just computed. And what do we get? We get an effect size of 0.54. According to Cohen's, okay, this is kind of a median effect size, okay? Around 0.5 is median according to Cohen. So so as I said, according to Cohen's, this is a medium effect size. What does that tell us? Okay, that's the next question. What does that tell us about practical significance? Well, it's just a proxy, as I told you guys. Okay, as I said, people with domain knowledge will have the final say on whether this difference between the two type of customers has any real impact. We need the input from domain knowledge experts. Okay. But, but, but at least we can claim something like this, okay? However, since the effect size is median, we can at least say that there is a non-negligible chance that people with domain knowledge will consider this effect as practically significant. So to wrap up, uh, the effect size is not perfect as a metric of practical significance, but it's definitely the way to go to get an initial idea of practical significance. And the way you interpret it is, okay, a small effect size, not very likely that people with domain knowledge will find it significant, practically significant. Medium effect size, well, it's likely that people with domain knowledge will find the effect or the difference as practically significant. And large effect size, well, then it's very likely that people with domain knowledge will find the effect as practically significant. All right. All right, guys. So this concludes this two-part video where I show you how to do a t-test, how to evaluate statistical significance, which remember, we evaluate statistical significance using the p-value, comparing the p-value to alpha. When the p-value is less than alpha, we conclude that the difference that we observe in the sample also holds at the population levels. In other words, when the p-value is less than alpha, we conclude that the difference is indeed statistically significant, but that is still kind of insufficient. We need a little bit more. So is that real statistically significant difference meaningful in any practical sense? And to that, you can get an idea about that using the effect size, using the procedure that I just mentioned, okay? All right, I hope you found the video useful, and I will see you in another video. Bye.